The Webb telescope is looking so far out that it's picking up light that's been traveling for over 13 billion years. Since the universe has been growing, this light has been stretching the whole way. This lets us see the most distant stuff out there. It is almost like looking back to the start of it all, the Big Bang. I know the universe is huge, but all of it started from what we call a singularity. At least, that's how we think of the Big Bang Theory. But guess what? The James Webb Space Telescope, JWST, has already shown us some weird stuff about how the universe was born and grew, which is pretty wild. Brian Cox, that physicist everyone likes, has even said that the cool finds from the JWST might change how we understand the whole universe. So, let's check out some of these new space findings that could change what we know. The James Webb Space Telescope, named after a NASA boss, is a seriously cool piece of space equipment. Think of it as a big jump forward from the Hubble Space Telescope. NASA worked with the European Space Agency and the Canadian Space Agency to make it. The JWST can do much more than Hubble. It uses the best tech we have to look at deep space with crazy detail. Unlike Hubble, the JWST takes clear, sharp pics of stuff far away. It mostly uses infrared light, which is cool because it can get through space dust and see stuff that was blocked from view before. It has a giant 6.5-meter mirror made of 18 hexagon pieces, which is much bigger than Hubble's mirror. It sits about 1.5 million kilometers from Earth, circling the sun along with us, so it gets a good, constant view. Looking into the far corners of the universe is not just about traveling across light years. It's also like a type of time travel. JWST uses infrared to watch space stuff from billions of years ago. Because the universe is getting bigger, the light from these objects gets stretched out a lot. This shifts it from the colors we can see into the infrared part of the light spectrum. Luckily, the JWST can spot infrared light from really far away. This lets scientists look at how stars come to life, watch how galaxies grew, and check out the air around planets outside our solar system. One of its latest big finds is spotting a huge group of galaxies at the edge of what we can see. This is causing people to rethink the theory of how things started, since how they were made challenges what we know. To get a better feel for this, let me give you a quick trip through the past of space stuff. Old groups like the Greeks and Chinese got things going by watching how planets moved. Isaac Newton's laws then, are the 1600s, provided a way to understand how space travel worked/could. In the middle 20th century, Edwin Hubble, a really important space expert, made big finds about cosmology. He found that galaxies that were far away were all separate so many galaxies beyond the Milky Way, which changed our understanding of how big the universe is and of its growth. Hubble's law showed that galaxies farther away were moving away quicker, meaning the universe is getting bigger. After World War II, the space race started with the Soviet Union beginning with Sputnik in 1957, the first satellite. Then, Yuri Gagarin became the first human in orbit in 1961, and Apollo 11 landed on the Moon in 1969. Then, in 1990, the Hubble Space Telescope gave us incredible pictures and facts from space. Going from these old observations to the new tech like the James Webb Space Telescope shows how much our understanding of the universe has improved. Hubble showed us how big space is and changed the main ideas in astronomy. Take Hubble, for example. It captured the cool pillars of creation in the Eagle Nebula, which showed a star-making zone formed from big columns of gas and dust. Another cool thing was the Hubble Deep Field, which showed thousands of galaxies in what looked like an empty part of space. The HST also has found components like water in exoplanet atmospheres, suggesting that there could be livable planets beyond our solar system. The pictures following the closest observed supernova, SN 1987A, it shed light on the life cycle of massive stars. All this made the Hubble Space Telescope important in the modern world of space stuff, stunning everyone with its big finds. The James Webb Space Telescope then builds on these advancements to learn more about model our understanding of the universe's origins. Around 13.8 billion years ago, the universe was really hot and packed together, and as this rapidly expanded, it created all matter and energy. As the universe got bigger, it also cooled down, which led to the formation of atoms, stars, galaxies. The Big Bang Theory also explains cosmic microwave background radiation, the components of light, and its big design. Even though everyone knows the Big Bang Theory, it faced issues when it started. Some models said the universe didn't have a beginning, and there were questions about whether certain proof supported this theory. A lot of these questions were resolved when cosmic microwave background radiation was found in 1965. These findings aligned accurately with the Big Bang predictions. Here comes the James Webb Space Telescope with its new infrared instruments designed to look through space dust. Working on infrared light, the telescope captures the oldest light in the universe and observes objects formed after the Big Bang. Using infrared lets it focus on spots in space where stars are being born, star nurseries, and formations that regular telescopes can't see. Infrared light has longer wavelengths when compared to visible light, making it perfect to see past interstellar dust. As space bodies move away, the light waves stretch, turning to longer wavelengths, the JWST spots this redshift, allowing scientists to study the start and creation of these objects. Energetic events like black hole unions or new star births frequently emit infrared as well. The JWST then strengthens the views from optical telescopes. Its capacity to detect infrared opens doors to peering farther out into space. The JWST serves as our peek into earlier phases of cosmic evolution and recently has shown things that may trigger a new look at our universe model. It's crazy how far away the Webb telescope can see. It's picking up light that's been traveling for over 13 billion years. Since the universe has been growing bigger, the light from really far stuff has been stretched out. We're basically looking back in time to almost the Big Bang. The universe is huge, but it all started from this tiny point called a singularity. That's our best guess about the Big Bang. Anyway, the James Webb Space Telescope, JWST, has already shown us some weird stuff about how the universe started and grew. It's mind-blowing. Brian Cox, this super smart physicist, even said that what the JWST is finding could totally change how we get the universe. Let's check out some of these new space findings that could change what we know. The James Webb Space Telescope, named after a big shot at NASA, is an amazing piece of tech for studying space. Think of it as a major improvement over the Hubble Space Telescope. It's something NASA, the European Space Agency, and the Canadian Space Agency built together. The JWST is way better than the Hubble. Its design helps us see the universe with a lot more detail. Unlike the Hubble, the JWST takes really clear pictures of faraway stuff in space, mostly using infrared light. This helps it see through space dust and spot things we couldn't see before. Its big 6.5-meter mirror, made of 18 hexagon-shaped parts, is bigger than the Hubble's. It's hanging out about 1.5 million kilometers from Earth, at a spot called L2, orbiting the Sun with Earth. This gives it a steady look at the universe. Looking at these far-off spots isn't just about distance. It's like traveling back in time. The JWST uses infrared to observe objects and happenings from billions of years ago. Because the universe is expanding, the light from these objects stretches out, shifting to the infrared part of the spectrum. Fortunately, the JWST can spot infrared light from really far away, so scientists can study how stars are born, how galaxies grow, and even check out the air around planets outside our solar system. One of its latest big finds is spotting a crazy amount of galaxies at the edge of what we can see. This makes us think our theories about how things started might be wrong, so we're having to rethink some basic ideas about the universe. To get a better idea of how we got here, let's take a quick look at the history of space study. Old groups like the Greeks and Chinese started figuring out how planets move by watching the sky. Newton's laws in the 17th century gave us a way to understand space travel. In the mid-20th century, Edwin Hubble, a major astronomer, made huge discoveries about space. He found out that distant nebulas were actually separate galaxies way beyond our Milky Way, which changed how we saw the size of the universe. Hubble's law showed that galaxies farther away were moving faster, which was proof the universe is growing. After World War II, the space race started, with the Soviet Union launching Sputnik in 1957, the first satellite. Then Yuri Gagarin orbited Earth in 1961, and Apollo 11 landed on the Moon in 1969, which were big wins. Then in 1990, the Hubble Space Telescope launched, giving us super clear, awesome views of the universe. Going from those early sky watchers to the Webb telescope shows how much we've learned about the universe. It showed us how huge space is and changed some basic astronomy ideas. Take the Hubble Space Telescope, HST, for example. It snapped the famous Pillars of Creation picture in the Eagle Nebula, showing a star nursery made of big columns of gas and dust. Another big deal was the Hubble Deep Field, which captured thousands of galaxies in what looked like an empty spot. The HST even dived into the air around planets outside our solar system, finding stuff like water and organic stuff, hinting that there could be livable places out there. Watching the closest supernova in a while, SN 1987A, it showed us about the life cycle of big stars. These things made the Hubble Space Telescope a legend in space science. The James Webb Space Telescope's main task is to build on all that and push things further. It follows the model of how we understand where the universe came from. The main idea is that about 13.8 billion years ago, the universe started as something super hot and tiny that exploded, creating matter, energy, and forces. As the universe got bigger, it cooled down, and eventually atoms, stars, and galaxies formed. The Big Bang Theory also says why we see cosmic microwave background radiation and why there's so much light. Even though it is mostly accepted, the Big Bang Theory had its doubters at first. Some people had other ideas, like the steady-state theory, which said the universe didn't have a start. And some were worried that there wasn't enough proof for the singularity. Most of these worries have been answered since. A big piece of proof came in 1965 when scientists found cosmic microwave background radiation. Also, space missions like COBE and WMAP and tech improvements helped the theory a lot. Accurate measurements of cosmic microwave background radiation fit really well with what the theories say. That's where the James Webb Space Telescope comes in. It sees right through space dust and spots stuff that formed right after the Big Bang. It gets to focus on where stars are born. Since infrared light can go through dust, the JWST can see through it, which the Hubble couldn't do as well. Also, the JWST can spot cooler objects that give off light in the space. When stuff in space moves away from us, its light waves get stretched, going to the infrared. Since JWST can spot that, it helps us to see what the universe looked like in the early days, events that use energy. The JWST can supplement this because it can detect with heightened sensitivity, provides great depth with this window, giving us a better view of universe development. The JWST serves as a window. Some masses were found on the side of discernible that have challenged models of the universe. The galaxies existed only a few million years after the Bang. We can understand system and planet structure and how they occurred. The JWST serves as an important milestone. Due to Hubble's age, there was certain light that blocked its progress. Hubble could never fully penetrate the light and the galaxies, while the JWST can observe bodies while using infrared. It showed galaxies with clarity. From models and discoveries, cosmologists had to argue over information they gathered, such as mass formations, numbers of galaxies, and some more developed galaxies than before previously discovered. Each model makes an avenue for further explanations by building on top of what's stated today. Even if Hubble was big during its time, JWST took discoveries for our exploration, which will bring more to what we are already given. Explorations in the field required many observations as explorations provide insight. JWST has made multiple observations of the different variations of signatures of universe development. The JWST does well in cosmos discoveries. Signatures such as carbon and oxygen show that there is valuable insight. JWST also is good with finding galaxies.